Okay, in today's video, we're going to look at some of the routing capabilities. All right, so I'm going to start off by making a digital clock. All right, so let's start with a basic MM1 queuing system. Okay. Um, Delete this one. Just hit it and hit delete, and then an end. Okay. And let's just, for the source exponential average into arrival time, um, 4 minutes. And the activity, let's make it we can make it an Erlang distribution with average parameter 6 and shape 3. Okay, let's save this first, and I'll call this one routing simulate. All right, let's just run it and see if it works. Okay. All right, it looks good. Okay. All right, now let's say that a certain percentage of the output has to be redone and perhaps put, in a different process. So let's make another queue over here, and another activity right here. So let's connect this queue to this activity, and once this activity is done, we can go to the end, and let's also connect that activity to that queue. Okay, so if we click on this activity 1 here, then we see the routing in and a routing out. Let's click on routing out. So the two destinations for activity 1 are end 1 and Q for activity 2. So this is Q for activity 2, and this is the end 1. Now, we can make a percent to say that the percent that go to end is, let's say 80% can go directly to the end, which means 20% have to go to the queue and do another process. And from here, we can reroute also back to here. And for activity 2, we can say that percentage-wise, so put a percent, let's say 90% can be finished, which means 10% would go back to the queue for activity 1. So let me just double check things. So clicking back on activity 1, the routing out, 80-20. Okay, that looks good. And for activity 2, looking at the routing out, 90-10. Okay. So let's do this slowly and see how it runs. All right, let's speed it up a bit. All right, so this queue seems to be getting full. And this queue doesn't seem to be. All right, so maybe we'll send a little bit more to this queue so we could see what happens. All right, so let's go to the routing, and let me change this to 60, and this one will be 40. All right, so 60, 40. Okay, and reset it. So now we have a little more coming here. And as you can see, it looks like both queues are getting utilized. And if we speed it up a lot, oh, it looks like we have a backup here, right? Average wait time. So if you just hover, you could see the wait times there. 418 minutes is the average wait time. And average wait time is 6 minutes. If you want to see what really happens, if like this, see is there a steady state, do it for a year and run it again. So yeah, obviously there's no steady state. See, 21,000. So it looks like we got to add another activity. So let's make another activity. Let me duplicate this one. You can just copy and paste it. Also, that works. I'm not sure where it went. Let me just duplicate it. All right, so duplication wizard. All right, so it's right here. If the arrows aren't right, you can change them. All right, so it looks like, let's check the routing. So reset it. Let's see how the routing is working. All right, so to see how the routing is working, let's click on activity 3. The routing in, it's coming in from Q1 for activity 1. So it's coming in from here, and the routing out, it's going to, it looks like it's going to end 1 and to Q2, just like the other one, which makes sense, right? Okay. You can also affect how the routing comes in by adding from someplace else. So we can have them go from after activity 2, it could come into after activity. See, we're looking at activity 3 now, right? So we can have activity 2 route into activity 3. It would go direct, which might be a problem. It might be better to have a queue in between. So we'll have to give it priority. All right, let's see how this works. Yeah, you can see it looks like there might be an extra arrow coming into activity 3 from activity 2. All right, let's speed it up. Okay. It looks like the queue for activity 2 is getting too full, right? So we could adjust, create new activities, experiment routing in and routing out. All right, so I guess that's how you deal with the routing. You can do pretty advanced stuff with the routing. And I think the final thing to show you is um, the resources, how the resources work. All right, so let me save this, and I'll start a new one. All right, file, new, simulation. All right, so let's start with a source, queue, and server, and an end. And let me have a resource here too. All right, there's the resource. And I'll connect the activity to the resource. I guess you don't do it like that. So, okay, yeah, activity. All right, so let's see. So let's put the, let's say the arrival time is, well, exponential. Average into arrival time is every, well, I guess let's say of 10 minutes. Every 10 minutes, a customer comes in. And let's make the service time normal with mean 30 minutes, standard deviation 5 minutes. Okay, let's save this. I'll call it resource sim. Okay, and for the activity, click on activity, then click on resource up here, and let's add a resource. Resource 1, and it starts with 10. So if you look at the resource, how many available? There's 10 available there. So let's bring it down to 2. This could be scissors, and the resource could be, the activity could be the barber, and the resource could be the pair of scissors. All right, let's save. All right, now it doesn't really, if you have only one activity, you'll never run out of resources. So why don't we duplicate this a couple times? So duplication wizard. Let's make 2 copies. All right, so now we have 3 barbers and only 2 pairs of scissors. All right, so let's see how it runs. Let's run it slowly first. See, I have the travel times not set to 0 yet. Let's see if anything changes. All right, so let me pause this. File, preferences, distances, set the travel times to 0. As I said, in real life, you probably would not want to set the travel time to 0 because they do have to get from place to place. But it doesn't really change the animation, but it changes the calculations. Okay, so let's speed this up. Let's run it for a year just to see what happens in the steady state.
Yes, sir.
Okay.
345? Yeah. You have any questions? No, sir.
All right, so as you can see, there's no there is no steady state, right? So do we need more barbers or do we need more resources, right? Well, it's easy to figure that out. So let's click the resource. Let's add 1 more resource. Okay. Save. Okay, now let's try running it with 3 pairs of scissors. Maybe it's the scissors that was the problem and not the number of barbers. That looks like that seems to solve the problem, but look at the average wait time for a haircut, 209 minutes. But it does seem to be a steady state. Like, how would you know that? We could run it for 10 years. Let's see if it changes much. Reset, run again. It looks like it's growing. 695. Maybe it is a steady state. Let's take a look at how many people are in this queue. Average is 69 people, and the average time spent 695 minutes. So it looks like it is, but it looks pretty big. So let's create one more barber, duplication wizard. One more. But let's keep the number of scissors at 3, right? Let's see what happens now. All right, hover over the queue, 723 minutes. So, see, by having only 3 pairs of scissors, it's like we're only being able to use 3 at a time. So, I guess it makes sense to invest in another pair of scissors, right? So, let's try that out. All right, and everything looks good now. Average wait time, 8 minutes. And one person waited 133 minutes, which is unfortunate, but that's in like 10 years. So average number of people waiting, 8.81. So less than one person on average is waiting for a haircut. And average time, 8.19 minutes. This non-zero only averages the non-zero weights. So it takes away all those zeros. So it only counts actual people and doesn't count all the time that there was nobody there. So, but the WQ that we're used to is right over here. See, it explains what things are if you just hover over the numbers. All right, so I think I've shown you everything you need to know. There's a lot more that this program can do. It's quite robust. It's an industry-grade program. There are a lot more videos online. Maybe just as a final thing, I'll just quickly show you some of the pre-built simulations. So let me save this. And here's some examples here, like a healthcare example. And let me slow it down a bit. See, here's a real-life simulation of an emergency room. You can play around with the graphics and do all sorts of fancy things. Maybe even make yourself a shipyard. Simulate a whole shipyard, or at least a simple approximation of a shipyard. So that might be a nice extra credit project. All right, thank you for watching the video, and we'll do these projects in class.